Hi everybody. We're trying a new setup here. Getting used to the pen still, and you might hear my daughter in the background crying because calculus makes her sad. So 6.2, we're going to continue to learn about definite integrals. Last class we just learned about how to rewrite the summation notation as integral notation. We did not use any calculus yet, and we're still not going to learn any calculus yet. We're just going to use geometry to find area under a curve. So what we said last class was that integrals use the summation of a bunch of tiny rectangles, well, tiny widths of rectangles, to find area under a curve. But this case, or this class, we're still not ready to learn that. We're just going to look at geometry. So I recognize this as being the formula for a circle that comes from x squared plus y squared equals r squared. That's the formula for a circle. But if you solve for r, you get r, sorry, not r. If you solve for y, you get square root of r squared minus x squared. Okay, well actually it's plus or minus. Because when you take the square root, you have to do plus or minus. This right here is just the positive half of that, so we're looking at a semicircle. So we're looking at the area from -2 to 2 of this semicircle, and the radius of this circle is 2 because in this case r squared is 4, which means r is 2. So we're finding the area of this semicircle from -2 to 2. And the area of a circle, we should know, is pi r squared. Well, this is a half of a circle because it's just the positive half. So it's half pi r squared for a semicircle. That's going to be 1/2 pi times the radius is 2. Oops. 2 squared, which is half of 4, 2 pi. Okay, so in this lesson, all we're going to get to is using geometry, not calculus. So we're going to do things like this. Can you please pause the video here to try and figure out what the area under this curve would be? And it's actually not a curve, it'll be a line. Okay, hopefully you graphed this. And you got 1, 2, 3 was my y-intercept. Slope of -3 over 2. Down 3 over 2. And I'm going from 0 to 2, meaning we're going to go from 0 to 2 here. Okay, we should notice that that's a triangle with height 3 and base 2. So we just do area equals 1/2 base times height, or 1/2 3 times 2, which is 6. Okay, one thing to note about this is that area, while area can never be negative, integrals can. So if I just change this problem a little bit and go from 2 to 4, we're still looking at that same line. But from 2 to 4, we have a triangle. 2 to 4, 2 starts here, 4 goes here. So it's 2 by 3 still. It's just, you know, the mirror reflection here. Okay? But this area is below the y-axis. Okay? Sorry, the x-axis. So that means that this area of my integral will come out negative. So even though area can't be negative, this will evaluate to -3. Okay, this integral here is -3 rather than, oh sorry. This was supposed to be +3 because half of 6. So that triangle was +3. This triangle is -3. Okay, so all I really wanted you to realize here is if something is below the x-axis, the integral will be negative, even though area can't typically be negative. So if you wanted to find the area and it's below the x-axis, you have two options. You can either find the negative integral. So, I had this written down before, but I might have cleared it out. So you could just do the negative integral of a to b of f of x dx. Or if you switch the order, it'll be a little bit more clear later, but if I say go from b to a of f of x dx, that'll switch the sign. So if I look at the last problem, where you look at this triangle down here, if I say go from 2 to 4, it'll be a negative area. But if I say go from 4 to 2, by switching the bounds here, if I say go from 4 to 2 of f of x, that'll just make it so my answer is positive. Okay, that'll make more sense next class when I show you how to actually evaluate integrals. But just know that if you switch the bounds here, the bounds b to a instead of a to b, it'll switch the sign. Okay, one last thing I want to look at here is, you're not going to have this on your homework for this class, but I'm going to tell you that the integral of sine of x from 0 to pi is 2. Okay, this area here is 2. Okay, so there's a couple things we could extrapolate from that. If I find the integral of 0 to 2 pi of sine of x, well, let's think. Sine is symmetrical, so this area is 2. This area would be the opposite. That total area would be 0, because I have 2 plus negative 2. Okay, if I had you find the integral from 0 to pi over 2, pi over 2 would just be 2 here. Take a guess at what you think that would be. Well, it's half of this, so instead of 2, it's 1. Okay? One of the questions in the book that I thought was fairly interesting is, what would the integral from negative k to kb of sine of x? Let's think about what that would look like. Ooh, not quite perfect. Well, let's try it again. So I'm getting used to this pen surface thing. So if I go from negative k to positive k, what do you think that area would be, no matter what k is? Well, on the negative side, that's all negative. On the positive side, this is all positive. No matter what, the area would be 0. So that's all for today's lesson. Thank you for watching. We will talk more about this in class. I hope you enjoyed your snow day.